Hello class, today we're going to be going over 5 different shapes that you will be responsible for knowing. The first of the shapes that we're going to go over is the square. Give me 1 second so I can construct this for you. It's not quite right. That's close enough. So on the square there is a couple rules that must be followed in order for it to be a square. The first is that all sides are the same length. So say this side here was 5 centimeters. This side here would also have to be 5 centimeters, as well as this, and finally this. Okay. Another thing is that all of the angles within the square have to be 90-degree angles, or right angles, which as you can see, this is, and all of these angles are the same. And the final thing that is important for a square is that opposing sides are parallel, as you can see. Now, if you follow rules 1 and 2, rule 3 will automatically be true, but this is just another thing to be aware of. The second shape that the class will be responsible for is the rectangle. Here is an example rectangle. You'll note some of the same rules that apply to the square also apply to the rectangle. As you can see, it has 2 opposing parallel sides, or 2 sets rather, and all of its angles are also 90-degree angles. The key difference between a rectangle and a square, however, is the sets of parallel lines are different lengths. So say this was 30 centimeters. These other 2 sides here and here would have to be a different length, say 5 centimeters. And that is important for all rectangles. Okay, it is possible for a rectangle to be a square, but it is impossible for a square to be a rectangle. The third shape is the rhombus. Most of you might know it as a diamond. Here is an example rhombus. Once again, you'll note that it has 2 opposing parallel sides. But that's where it starts to differ from the examples that we had before. You'll notice that here and here, these 2 angles are definitely greater than 90 degrees, and these 2 angles here and here are smaller than 90 degrees. A thing to note is that the opposing angles, though, are the same size. The last rule for a rhombus, for it to be a true rhombus, is all sides must again be of equal length. So say this was 5 centimeters, this would have to be 5 centimeters, and the same with these other 2 sides. Now, the shapes that we just covered are all part of a larger group called the parallelogram. And basically, for a shape to be a parallelogram, it has to have opposite sides that are equal and parallel, sorry, tongue failed me for a moment, and the opposite angles are equal. So as you can say, or as you can see, opposite sides are parallel on all three of these shapes. And please forgive me my terrible penmanship. And the opposite angles are all the same. Now on a square and a rectangle, that's a given since all angles are 90 degrees. But on the rhombus, you have to be a little more cautious because you will have two different size angles in the rhombus. The final shape that we have is the trapezium. Now, many of the rules that apply to parallelograms do not apply to the trapezium. So I'm going to actually construct this in front of you. So in the trapezium, you will have four sides as well. So there's 1, 2. Give me 1 sec, gotta get this right. Three and four sides. And only two of the sides are parallel. As you can see, these two sides here are parallel, whereas this side and this side definitely are not parallel because they will intersect somewhere up here. So, another thing to note, because these two sides aren't parallel, all of these angles have to be of different sizes for it to be a true trapezium. And to end the screencast for today, I thought I would just leave you with a nice image that tells you all of the rules. And over here is the link where you can find more materials around that.